Okay, section 1.4, we are continuing down a path, or continuing paths. All right, so we've seen this definition of a path as just what we would call a parameterization of the x and the y. Kind of any smooth curve could be eventually described somehow as a path, but usually we take paths because of their description. So let's look at a couple paths. Let's go from 0, the origin, to up here at maybe this would be z equal, let's make it 1, 1. So we'll say this is 1 plus I. Okay, so we have our x and our I here, our real part and our imaginary part. And so, really any path can get you there. But for instance, one perfectly good path that's made up of two segments, a horizontal segment and a vertical segment, like that. What I can do, so this goes to 1 right there, and then up. And so if I were to describe this part, this first part, I could just have gamma of t equal, well, the x goes from 0 to 1, so, I can just say, use t, for instance, and then plus 0i, right, because it's on the real line. And so that, I would very easily describe as 0 to t from 0 less than or equal to t less than or equal to 1. Now up here, the first thing I would come up with, the first thing I would think of here would be gamma of t is equal to, what do I want to say here? 1 plus it, and again have 0 less than t less than 1. Okay, so this actually doesn't fit our definition of path, in that I have t going from 0 to 1 and then 0 to 1. So, I could fix this up and do a piecewise definition again. And so, I would let it be t, say from 0 to t less than 1. And then I need this thing to actually go from 0i to 1i. But I would like probably t to go from 1 to 2. And so this will be 1 plus I times, well, if I just take t minus 1, that will start me at 0 and finish me at 1. And so that would be, say, our definition of our path. Now, though, let's look at what this means. Is I follow t from 0 to 2, I'm going this way, and I'm coming up there, and then I'm going that way. So there's a particular orientation. Now, another perfectly good path would be actually from I plus, or 1 plus I back to 0. So, you know, I could think, you know, every path has an orientation, and the question is, well, you know, am I going from 0 to z here, or am I going from z to 0? And so I could have what looks like the same path, but now my orientation would go this way. And so it gets a little harder for me to come up with that parameterization. But again, I know I'm going to need two. I'm going to pick the first one, 0 is less than or equal to t less than or equal to 1. And then the second one, 1 less than or equal to t less than or equal to 2. So now I'm going to do the second one first, because I have to go from the number 1 down to the number 0 as t goes from 1 to 2, right? But again, we know how to do that. We could we could think of it as a straight line here. And so I have at t equals 1, I need to be at 1, and then at t equals 2, I need to be at 0. Can I come up with that line? And certainly I can. The y, you know, so I'm taking 0 minus 1 over 2 minus 1. That's my slope. And so my slope is negative 1. And if I use the point slope form, say with this, 2 and 0, then what I know is that, you know, if I'm thinking of this as y equal mx plus b, right, y is negative 1 times x minus 2 plus 0. And so y equals negative x plus 2. Now let's kind of think that through and make sure that that's right. If t is 1, and so if I put 1 in here, I'll get negative 1 plus 2 is 1. If I put 2 in there for x, I'll get 0. So yep, this I want to be negative t plus 2. And that will get me from here to there, and no imaginary part. And now this part, I can fill in the real part. I know the real part's 1. And what do I have to do for that? Well, for the imaginary part, plus I times, well, I times what? Well, when I'm at 0, I want to get 1. And when I'm at 1, I want to get 0. Oh, so that would just be 1 minus t. Again, I could calculate that 1 minus t the same way, is that, you know, for t equals 0, I want to get 1, and for t equal 1, I want to get 0. And, you know, so the slope here is negative 1 as well, and I'd have y equals negative 1, and a y-intercept of 1, so negative 1x plus 1, or in other words, minus t plus 1, which is what I've got here, 1 minus t. Okay, so if, you know, if I'm just looking at the path with no orientation, it's the same path. This path looks the same as this path. Well, there's where I defined it. Okay, but notice the algebra is different because I'm going in a different orientation. Okay, now in the end, if I'm doing practical stuff, I'm probably not going to work this hard at, you know, coming up with a interval a to b, you know, from 0 to 2 like that. Probably if I'm just working on something and I I need to use the path, I'll probably just start over. Okay, so I probably, if I wanted to use this path that went from 0 up to z, I probably would indeed just use this and just start t over at 0 again, because it's just easier for me, right? I knew I needed the 1, but then the I times t. And so that is more about looking at paths, but also constructing them. And we see we can have a path with these horizontal and vertical segments. And again, if I do segments, I'm probably not going to work that hard most of the time on figuring out t. I'm usually going to probably just have t go from 0 to 1. And along those lines, let's look at a path that goes straight to z here. So z equals 1 plus I from 0 here. Z equals 0. And now in this case, right, if I think about it as coordinate pairs, I've got 0, 0, and I'm going up here to 1, 1. Now, to fill in a line segment, whether it's horizontal, vertical, whatever, all I have to do is, if I, so I'm going to say from x1, y1 to x2, y2. So if I want to fill in a segment that just goes straight, excuse me, from some x1, y1 to some x2, y2, so just a straight line, what I'm going to use is that my gamma of t is equal to, for the x's, the real part, so it says I'm going from x1. So I'm going to do 1 minus t times x1, and then 2x2, so plus tx2. Okay, so there's the real part. And then plus I, and 1 minus t y1 plus t y2. And this is for 0 less than or equal to t less than or equal to 1. And that will always create that line segment between the 2 points. And it's always from this x1 and to that x2. So in this case, if I'm going from 0, 0 to 1, 1, then this gamma of t is equal to, well, x1 is 0, so that just disappears, and x2 is 1, so I get a t. And then the y1 is 0, and the y2 is 1, and so I'll get another t there, it, and that's 0 less than or equal to t less than or equal to 1. Okay, so this is when you do this sort of thing with the 1 minus t and the t between 2 points, that's called a convex combination. That is a great way to create a line segment between 2 points. Okay, I think that's enough for this part of paths, so we'll stop there.